Number 29. If air is 20.9% volume, how many liters of air are needed for complete combustion of 20 liters of octane vapor, which is C8H18? And so we're starting from this liters of C8H18, but we're talking about, we're given information in terms of octane, but we're being asked for information about oxygen. So we're going to have to be doing some sort of stoichiometry, right? That's what this section is about. Section 3 is we're going to need a balanced chemical equation. So we are combusting, right? Complete combustion. So it's going to be our C8 plus oxygen reacting to form CO2 and water. Oh, I got off the camera a little bit. Now, spoiler alert, end up being 2, 25, 16, and 18. Okay, I'll save you a little bit of time by just burying the lead right there. So we have our balanced chemical equation. Now, if that takes you 5 minutes, spend 5 minutes on it, right? You have to have the correct balanced chemical equation or you cannot proceed on these stoichiometry problems. So the problem gives us 25 liters of C8H18 to start with. We are going to have liters of C8H18 and into liters of oxygen. All right, once we do that, liters of octane will cancel with liters of octane, and we will be in terms of liters of O2. Okay, and from our balanced chemical equation, the ratio of to oxygen is 2 to 25. During 12.5. But this is not our answer, right? We're being asked for how many liters of air. We know that air is 20.9% oxygen. Now, if you're unfamiliar with this technique, don't sweat it. But all we have to do is divide by the decimal of that percentage. Right? Hopefully you guys remember the relationship between decimals and percentages from math class. That we will actually get the total volume. All right, so divided by a point. Now I got a pretty big number there, 1,495.215311. But I do want to consider the appropriate number of significant figures. The question gave me 3 sig figs to start with, so I'm going to end with 3 sig figs. That would be right there. That 5 tells me to turn this into actually 1,500, but 3 significant figures. So the way I can accomplish that is by 1.5010 to the third liters. All right, put that into scientific notation. I get to include the number of sig figs that I want, right? Or I guess I should, and still show the correct value. B, what volume of each product is produced? We know a couple things. We can start from a couple of places. We can start from there. We can start from there. To be honest, I always prefer to go beginning, because just in the possibility that this is the incorrect answer. I mean, it's not, but just by chance, if this is the incorrect answer, I don't want the fact that I generated the incorrect answer here through some silly mistake to mess up my potential points for this next part. So I'm actually going to go back to starting 25 liters of octane. Okay. Now again, I'm going to be converting out of liters of octane and into liters. Let's see, I'm going for each product. So one of the products is CO2. That'll let me cancel and go into liters of carbon dioxide. I'm going to go ahead and set up my other conversion into the other product using same setup. Convert out of liters of octane and into liters of the other product. And that'll get me an answer in terms of liters of H2O. Plug in the numbers for my balanced chemical equation. Ratio is 2 to 16, 2 to 18. Ready to calculate. So 200. So I'll just put a decimal to make both those trailing zeros significant. And one more time. Oop. And 225. So as a result of this reaction, I will produce 200 liters of CO2 and 225 liters of water vapor.